This is a brief topic which I think is worth a mention, and it does come up in your regular textbook as well. I really don't do anything with it because it's such I think a very intuitive or obvious type of construction with functions. And we can do arithmetic with functions. You can add them, subtract them, multiply them, and divide them. And so for example, suppose that f of x was the function 2x minus 3, and g of x is the function x squared minus 1. So we could add these functions together. F of x plus g of x would simply be 2x minus 3 plus x squared minus 1. And I suppose we ought to simplify that. This would be x squared plus 2x minus 4. Alright, now we could subtract functions. We could multiply them. And we can divide them. And all of these would be probably exactly what you would expect. For example, what's f of x over g of x? That's simply 2x minus 3 over x squared minus 1. We call this a rational function. A rational function is a ratio of polynomials. Great. We can multiply them together. We can subtract them. So I think all that is pretty self-explanatory. Just wanted to mention it to you. Now, your textbook uses a notation I don't particularly care for, and one I don't use. But and some textbooks do this, some don't. I think most of them do it the way I show it. You know, to me, this looks very intuitive. This says, well, add those two functions together. But your textbook would write it f plus g parentheses of x. Okay. So that is a valid way to represent a sum of two functions. It would be valid to represent a division of functions like this, f over g of x. So I don't like this kind of notation. I've got it all mapped out in my book. I don't care for that because it just doesn't seem as natural to me. So, but I think you should be familiar with it in case you should see it after this section in your textbook. All right, now there is a type of operation with functions we will study in some depth is composite functions. So a composite function is inserting one function inside of another one, where the input of a function is a different function. That's important. So we're gonna study that in a later topic.